Hello, everybody. Thank you for tuning in. My name is Daniel, and today I will talk about conquering configuration constraints, real world patterns for distributing data at scale in Kubernetes. So, what does that all mean? Before I answer that question, I will be talking about configurations in general in Kubernetes. So, I looked up some statistics on what sort of applications are running in Kubernetes, right? So this is from Red Hat. As you might see, there's all these different um, example applications for all these categories, and you'll notice pretty much all of them are not Kubernetes native. What this means is essentially they are just regular applications that can run on-prem or they can run on Kubernetes. You can run it anywhere, and they have no idea where they're running. They have no idea how to access the Kubernetes resources. All they use are the native OS file system APIs, and to them, it's just a normal operating system. So, how are they configured? There's many different flavors. You have your trusted friends, JSON and YAML. You have your old school methods of configuration. You could use a text file. You could use XML if you're still old school, or you could use any files common in Windows, or you have the next cool things, TOML or RON, or you can even use a custom text-based or binary configuration. Okay, so what is this presentation about? So you probably know how to store configurations for your application to consume, but you may not know some of the pitfalls. So I will start by sharing the best practices regarding storing configurations and the pitfalls associated. And then I'll go into custom resources as a configuration. And let me give you a spoiler alert. They are not easy to get right. They typically are operated by an operator, and those things have their own little pitfalls. So I'll be talking about that. And finally, I will give some advice on what we can possibly do about it. So who am I? As I mentioned, my name is Daniel. My picture there is a little bit outdated, but whose is it? I've been working in the observability space. So previously, I've worked on the Google Cloud Managed Services for Prometheus, which I will call GMP moving forward. Nowadays, I'm working on Monarch alerting. If you don't know what Monarch is, it is our planet scale time series database at Google. Previously, in a different life, I was a senior web developer at the Intercontinental Exchange. And let's get right into it. So let's start with config maps. This is what everybody knows. It is the most obvious choice. It's probably your go-to. You just take your configuration and you just take that raw string and you stuff it into this config map object. And then when you want to use it, the most easy way is in your pod spec. You just add a fresh volume and mount it into your container. What do I mean by free-ish? I mean that there's no charge on most cloud providers to create. So hypothetically, you can create an unlimited amount of them, and you won't have to pay extra. For your sensitive data, you have secrets. They have the same exact properties. It's a little bit more special because it is a more hidden or controlled resource. Typically, you want to lock this down as much as you can so that you limit which applications can actually access this, and only ideally give it to the right applications. Next, you might have configurations of configurations. So, for example, in this over here, I have a Prometheus configuration, and you can see within the configuration, the config.yaml, You have a field that points to another file, and that file is also handled by the same config map. So you see config.yaml has a TLS-CA certificate, and that is handled as a separate key here. Why might you do this? It might be just easier to reason about. You have several sort of independent configurations. It's a lot easier to keep track. It might help with reusing things if you use this certificate in various parts of your configuration. You can just simply extract it into another file, and you can refer to it multiple times. Sometimes you have to do this because whatever application you're using works that way. It needs multiple configuration files. And finally, there's different types of configurations occasionally. In this example, I put everything into a config map. However, a certificate is usually a secret, so you can have your main configuration in a config map and your certificates in a secret. As I mentioned before, you use the keys to split them up, and when you mount them, they each translate into individual files. From here on out, I will be calling this concept as aggregation, because you're sort of taking all these individual configurations and you're sort of aggregating them together into one config map resource. So what's the catch? First of all, the data is untyped, right? So a typo can actually break your application. And it's a little hard to discover. You won't be able to know until you check on your pod and you notice it's crashing. Other times it's a runtime problem and you won't notice until you actually see what your application is doing and you notice it's not working at all. So it can be a little bit hidden and hard to discover. Next, I mentioned the unlimited aspect. Well, after all, it's not unlimited. There are limitations on these things. And so there's something called etcd, and this is the backing store for the Kubernetes cluster data. So all your config maps are stored in etcd. With etcd, there's a 1.5 megabit default request limit, so your config maps can't be over. You cannot have a config map that's 2 MB bytes. You can configure it, but you cannot configure it on clouds. Finally, a third problem is that you may need to restart your pod to pick up some of these configuration updates, right? So you can update your config map, but sometimes they won't take effect until you restart your pod, and your pod reads the file system again and picks up the new configuration. That is very application dependent. So you might have an application that uses file system watcher. In that case, it'll be automatic. If not, you do have to restart your pod. So regarding the file size limits, one way to solve this is the disk. So you have volumes which don't have a disk, but they're still limited in some ways. First of all, they're not free. So you check with your provider how much they cost. Although the cost is negligible, you're still paying something, and it's a recurring cost that you have to keep in mind. Another thing is that there are no detachment limits. So depending on which cloud provider you use, there is a limit on how many volumes can be attached to a single node. So you have to keep that in mind as well. You can't have too many of them. Finally, they're more complicated to set up. So there's all these different things you have to worry about. There's different pricing tiers for different configurations. And so you might have 2 volumes that look the same, but they aren't, because you might be paying for a faster one. So there's a sort of a mismatch there. Finally, more complicated setup makes it more difficult to test. Like if you're setting up a kind cluster or whatever, you just have to you have to add more setup code to actually set up a volume and do some integration tests there. Kubernetes does have solutions for this, so they have some abstractions for the disk. So you might have heard of CSI, which helps bridge the gap between some of these different cloud storage providers. That way you can easily create a a volume using just the Kubernetes APIs, and this relieves some of those setup headaches. Finally, there's also a capability to convert a volume into a config map or a secret if you prefer that. So you can use this application called the Secret Store CSI driver. And there are some headaches involved, obviously, with this approach because there is more to set up, but it's significantly lessened. It's just a more roundabout solution of getting what you want. Okay, so how can we improve some of those other problems or some of the problems with disks as well? Well, the first problem I mentioned is that the data is untyped, so a typo can easily break your application. You might not notice right away. So how can we prevent that? And so one of the ways is to have a custom resource. So in this example, we have Prometheus. Specifically, this is Prometheus operator versus a Prometheus scrape config manual configuration. And as you can see, the custom resource version is a lot less dense. It's a lot easier to reason about. And ultimately, it generates the one on the right. So they are equivalent. But with the custom resource, if you make a typo, your then there will be some validation, and it'll sort of warn you, or it'll reject the update altogether or the creation. So how do custom resources work? For those who don't know, there's typically an application called an operator which manages these things. It sets up definitions usually. You'll install a manifest that defines both the custom resource and the operator. So if you usually install both at the same time. As I mentioned, there's a validation aspect to it. So if you try to push an invalid update, it'll get rejected. It won't go through, or it could even give you a warning saying, hey, this is fishy. Can you please take a look? But they'll still accept it. Finally, there's defaulting. So if you don't set some values, your operator will set some values for you so that when you go and look at the custom resource after you create it, you'll see all your values right there set, even though you didn't specify them originally. So operators can also manage your application, so it knows when to restart the pod. As I mentioned earlier, one of the problems with configs is that if your application doesn't have a file system launcher, then you'll need to restart your application whenever you update the config, right? So if you have an operator, it'll see the custom resource coming in. It'll tell your application, hey, I have a new version. Can you restart for me? So this is only possible if an operator already exists with the custom resource. Maintaining an operator is hard, and I'll go into why shortly. I do not recommend creating your own operator just to get a custom resource, although custom resources are really, really nice. So let me talk about why they're hard. First, let's talk about validation, right? So I mentioned that an operator can do validation on behalf of you. However, the actual validation always happens on the application level. So there's a sort of mismatch there, right? So you essentially have two applications who are both doing validation. So one solution to that is to reuse the configuration to use the same library as the main application to validate the configuration, which is all fine and dandy until it's not. So if there's an application version mismatch, so for example, if your operator, it has one version of the validation library and your application has another version, that can cause some issues. So another option is to just have the operator call out to the application itself. right? So there's different ways that might happen. You might signal to the pod or ask it to do some validation, and there's some communication there, and it'll tell you whether or not that was successful. This can be tricky depending on how you do it. For example, if you restart the pod, um, if if you push the configuration and restart the pod, and the configuration is bad and it starts crash looping, the operator has to handle that. So that is a sort of an edge case that you would have to handle. An even better solution is if the application had some support for dynamically reloading the configuration. So this is that file system launcher approach that I mentioned earlier. The problem here is that your application must support this, right? So if you don't have this, then you have to look for other solutions. Um, Ideally, with this method, your application should be able to recover to the last known good configuration. So, for example, if you push a bad update and it's not good, then it should restore your last good update, and that's so that you have a single source of truth, and you know exactly what the live configuration is. So you can always check on it, and you can see, okay, this is when my application's actually running. My last update didn't go through, but I can see this is running. All right, so how do they actually work? Unfortunately, they do exactly the same thing that you would have done manually, but it just does it automatically for you. So I mentioned usually you would start with a config map or a secret. So an operator just takes that custom resource and just converts it to the config map or the secret. So we have all the caveats there. So we have the size limit problem, and this is still a sort of hidden problem. You can just start pushing all these custom resources, and you won't know that it's causing problems until much later. So that's not good. A solution to the size limit is to use a disk. However, with operators, they are not trivial to set up. Operators cannot create disks; they can only use them, right? So what I mean by this is that it might be bad practice for an operator to create a disk on behalf of the user, because disks are such a costly resource. The next problem is that in order to actually use the disk, it would have to mount the disk to its own deployment or whatever workload the operator is running on, and this also has a security implication, right? So if you were using a config map or secret, you can fetch it via an API. If you're using a disk, that's a little bit harder. I, there might be a way to do this in a in a in in a portable manner, but I don't know of it. As I mentioned earlier, it's not free. It gives a cost to the actual operator, right? So this operator that you're running is not free. It wasn't really free to begin with because you need to have CPU cycles to run this operator, but now this just further increases the cost. So you might be if you write operators, you might be compelled to go back to config maps and secrets. Okay, this next problem is that the config maps or secrets must be mounted, right? So you can't just create one and the application will just use it. It has to be defined beforehand. And if you were to add any new config maps or secrets, you would have to add a new mount point, and that would restart the pods, regardless of whether your pod has a file system launcher. If you add a new mount, your pod will just automatically restart. In order to do this, you would need to be able to edit the pod, right? So this is more security that you would have to give more permission to your operator, and that could potentially be a security concern. So the GMP, when I was on the GMP team, we had a solution for this, and it was to aggregate configurations together. I mentioned this as a technique earlier. So you take a bunch of configurations and you just put them all together into one config map or one secret. And again, that works until we have the size constraints. And this is sort of what an example would look like. So one solution to the size constraints is actually sharding some of these config maps. So for example, you can aggregate all the config maps into all the configs into a single config map, and then when you exceed that size, you can you can create another one, and then you can mount that, and then that sort of minimizes how frequently you have to mount. The way this would work when you mount these on the pod is you would use a projected volume mount, and that would just let you mount as if you had a single config map. Even though you have two, you would sort of mount them in the same spot. So then, as long as the keys don't overlap, it'll look like it's a single config map to the application. And that's just an example of how it looks. It's a very easy API. You just tell it, okay, here are all the config maps that I want to mount at that spot. One challenge with this is daemon sets and replicas. They're a lot more tricky to support, particularly because you have all these different pods, and if you mount something new, then all of them would have to restart. So that is a challenge. One way to solve this is, instead of mounting, you can do an API access from the container. That's hard to do unless you code that into the application itself. For GMP, we actually did that. We forked Prometheus and we do it in there. Alternatively, you can use a sidecar. And a sidecar is a special container running within the same pod of the application container, and it calls the Kubernetes API. It gets the result, stores it in an ephemeral volume mount, and then you mount that volume to the application. So you have a sort of other application doing all the fetching and all the updating, and then your application just runs as usual. There's also this problem of data consistency. So regardless of wherever the data is stored, config maps or disks, the data should remain consistent, right? So if your operator takes your custom resources, converts it to a config map, the problem is anybody can go and edit that config map. So you have to have a way of preventing that, right? So one way to do this is to use the Kubernetes Watch API. You can actually also use webhooks, so that if you ever see a third-party application or user trying to edit a config map, you just deny it. So that's very important to have. That way you have a single source of truth. And again, like, you want to know what the configuration actually looks like. Sometimes you might have secrets that live in a different store. How do we solve this with operators? And the solution is actually quite simple. You watch for it wherever it is, and the operator can just aggregate it into a native Kubernetes secret. So I might say it's simple. It's actually not, because you need a way to watch it, and depending on your store, you would need to have the operator support those APIs. So it's a lot easier said than done, but it is possible. So I mentioned sidecars earlier. There's more that you can do once you get into this territory to sort of solve some of these issues that I mentioned. To recap on how the on how the sidecar works, the sidecar just listens to the data, listens to the config map, and it just clones it into a temporary disk called an ephemeral disk, an ephemeral mount, and that gets mounted onto the actual application. And so you can use this to do all sorts of processing. So, for example, you can have it communicate with the application on every reload. So, for example, if you push an update, your sidecar can notify your application of the update. And if it's invalid, the sidecar might store the old version in memory, and so it can revert it, and you'll be able to debug what the actual application is. And there are tools that kind of do this for you as well. There's some sidecars already. There's a popular reloader tool, which is real great, or the one in GMP that we use pretty frequently. It comes from Thanos, called the config reloader. So you can have another sidecar if you want to reduce memory. If you want to reduce the size of a config map, one thing you can do is add in templating. So this is nice if you have a configuration that has a lot of repetition, right? Because you can kind of take all that repetition, turn it into a variable, and just expand that variable later on. So the sidecar, it watches the config map, and when it sees an update, it does the templating, and then it writes it to the mount, and then the application just uses the expanded configuration. It doesn't even know it's been expanded. You can do the same with compression, right? So the operator can write a compressed config map, and then the sidecar reads that config map and decompresses it, and then puts that into the mount, and then the application just uses that. So that can give you a really quick and easy win if you want to get the size down. This is what we did in GMP when a lot of customers were saying that that their application was suddenly breaking, and they needed because they had 1,000 custom resources, and we needed a quick and easy way to do that, and so we turned to compression. So to conclude, there's a lot of room for improvement. We've only skimmed the surface, but configurations are hard, right? There's many of these unexpected issues that must be worked around that I mentioned earlier. For example, the size constraints, the maintenance costs, so like the setup, the organization. For example, if you want to even do aggregation, that's a question that you have to ask yourself. There's the question of how ergonomic it is. So like if you're not using a custom resource, it may not be the most ergonomic way to do it. And you can use an operator, which are great, but they're very, very difficult to maintain. As I mentioned, all of these edge cases you have to solve within the operator, and that is very difficult to get right. It also does require some application support to get it right. So you might not be able to get all the benefits of using an operator just by creating one. Finally, sidecars can give you some quick wins, but they're not very universal. So you can't, again, they have to kind of support various functionality of the application. Some ideas I had for the future and how we can improve this are maybe some common configuration reloading APIs. So, for example, Prometheus has a reload endpoint. We can maybe also add a validation endpoint. We can have common file system watching libraries to ensure that that configurations are loaded dynamically. We could potentially create a universal configuration operator. I don't see why there has to be a different operator for everything if they're all doing the same thing. So they can do things like the automated aggregation, it can do sharding, and it can also guarantee the consistency of the config map within the Kubernetes API. Maybe we can create some common sidecars that would do the dynamic mounting, the variable expansion, and the templating. So Thanos does the last two, so it's already there, but again, your application has to support it. And maybe a last idea is maybe we can have flexible Kubernetes APIs for mounting. So you can maybe avoid restarting pods whenever you mount something new. Or maybe we can even create something more ergonomic where you can group config maps and not have to do some projections or mounting in general. And that's all, folks. Thank you for watching. Leave comments in the video. Thank you. Bye.